Okay, I want to look at another example where I have a parabola given by this equation. The equation is p2 of x equals a2x squared plus a1x plus a0. And I want to find out if a parabola exists that contains these 3 points. So it goes through these 3 points. The first point is x equal 2, y equal 2. The second point is x equal negative 3, y equals 1. And the third point is x equals 3, y equals negative 4. So what I need to find to solve that equation is I need to find the values for each of these coefficients, a2, a1, and a0. So in order to do that, I'm going to write this equation like this. Y is equal to a sub 2 x squared plus a sub 1 x plus a sub 0. And now I'm going to write down my 3 equations, one for each pair of points. Okay, so the first equation I'll write in red. X is equal to 2 and y is equal to 2. So that equation I write as 2, that's y equal to 2, equal to a2 times x squared. Okay, x squared is 2, so x is 2, so x squared is 4. So that becomes 4a2, and then plus 2a1, plus 2a1, plus a0. So that's the first equation, okay? First equation in red. Now the second equation I'll write in green, and it's for this set of points where x is equal to negative 3 and y is equal to 1. So for y equal 1, I write 1 is equal to a negative 3 squared is 9. So I have 9a2 plus negative 3a1. So I want to take out that plus sign and write a minus sign. So I get negative 3a1 and then plus a0. And then I'll write equation in blue for the third point, where x is equal to 3 and y is negative 4. So I'll write that as negative 4 equal to 3 squared, again, is 9, so I get 9a2. Now x is plus 3, so this becomes plus 3a1 plus a0. So I have these 3 equations, and I have 3 unknowns. So here's one equation right here, or one set of 3 equations. 3 equations, the unknowns are a2, a1, and a0. So I want to solve those equations for a2, a1, and a0. So the first thing I might do here is to, let's say, subtract the blue equation from the green equation. So let me write that down right here. The green equation is 1 equals 9a2 minus 3a1 plus a0. The blue equation is negative 4 equal to 9a2 plus 3a1 plus a0. Now if I subtract the bottom equation from the top equation here, a0 from a0 gives me 0. Plus 3a1 subtracted from negative 3a1 gives me negative 6a1. And 9a2 subtracted from 9a2 gives me 0. And negative 4 subtracted from negative 1 gives me a 5. So I have 5 is equal to negative 6a1, or I divide both sides by 6 and I get negative 5, 6, negative 5 over 6 is equal to a1. So I've now solved for one of my constants right here. Okay, now let me solve for another one, and let me take this equation on top, and I will subtract it from the red equation. I will subtract from the blue equation. So the blue equation looks like negative 4 is equal to 9a2 plus 3a1 plus a0. And I'm going to subtract from that the red equation, which is 2 equal to 4a1, or sorry, 4a2 plus 2a1, this is a1 here, plus a0. So I subtract, okay, a0 from a0 gives me 0. Subtract 2a1 from 3a1, it gives me a1. And I subtract 4a2 from 9a2, and it gives me 5a2. And I subtract this 2 from negative 4, and it gives me negative 6. So I have negative 6 is equal to 5a2 plus a1. And now what I want to do is I want to substitute in the value I've already computed for a1 right in here. Okay, so I get negative 6 is equal to 5a2 and then plus a1, but negative 1 is 5 over 6. Now I want to solve for a2, so I bring the 5, 6, add 5, 6 to both sides, and let me write this negative 6 as being negative 36 divided by 6. Bring 5, 6, add 5, 6 to both sides, so I have negative 36 over 6 plus 5, 6 is equal to 5a2. So I add this up together, and I get negative 31, put them over as common denominator. Excuse me. Negative 36 plus 5 is negative 31 over 6, and that's equal to 5a2. And now divide both sides of the equation by 5, and I get negative 31 over 30, and that's equal to a2. So here's my second variable a2 that I found the solution for. Okay. Now with that, let me take all of these out, okay, and erase it to give me some space. And let me move this up into the corner. I'll move it down here right there. So I have a1 and a2 there. Now I still have to solve for a0. So to solve for a0, I'm just going to use the green equation right here, this equation right in here. So I have 1 is equal to 9a2, but I've solved for a2. a2 is negative 31 over 30. So that's 9 times negative 31 over 30. Net minus 3a1, so minus 3, and I've solved for a1, which is equal to negative 5 over 6. So that's negative 5 over 6 plus a0. Okay, now let me use a little algebra here. I have 1 over here, so still 1, is equal to, now 9 times negative 31 over 30 looks like 279, negative 279 over 30. Let me make that a little bit larger, negative sign. This is a plus 15 over 6 plus a0. Now, I can reduce these fractions just a little bit. I have 1, and numerator and denominator here are both divisible by 3. So this becomes negative 93 over 10. And this right here, numerator and denominator divisible by 3, this becomes 5 over 2. plus A0. Okay, so let me bring these over to the other side of the equation. I get 1 plus 93 over 10 negative 5 over 2. Let me put that over 10. That's multiply numerator and denominator by 5, so that becomes minus 25 over 10. Okay, and that's equal to A0. So let me write 1 as being 10 over 10. So I have 10 over 10 plus 93 over 10 minus 25 over 10. And that's equal to A0. So these are all over a common denominator. So 10 plus 93 is 103. And 103 minus 25 over 10 is equal to A0. And 103 minus 25 is 78 over 10. So I have this as 78 over 10. And 78 over 10 becomes 39. Divide the numerator and denominator with 2. This becomes 39 over 5. So A naught is 39 over 5. So this is the third parameter. So presumably now, if I use these three values for A1, A2, and A0, I will solve the equation. So I will look at that in the next video.